All right. Producer, new broadcast, GHC data set, Kaggle stream. All right, all right, all right, all right. Cool. We're live. We're live. It's gonna be a short one because it ended up being late, and my baby is, I think, kind of like not fully um is asleep, but he wakes up often, and I can't. I'm on night duty today, so. All right. So, what are we going to explain today? Today, we're going to talk about the GHC dataset. For those who don't know about these, you can go straight into uncertain dot systems and you can take a look at the tools, and then you will see that we have obviously Open Lesson, which is the tool, is our flagship tool, which is already alive, and then we have three other tools in the stack, and here's our beautiful roadmap. So the GHC data set is basically something that is kind of built on top of the concept, or sort of alongside of the human cognition data set, the GHC data set and the GHC benchmark, sorry. So they're both kind of like, in a way, hand in hand go together, right? So what the GHC benchmark tries to do is tries to understand how closely an AI chain of thought really matches real human thinking. And there's many ways you can approach this topic, of course. But one obvious way to do so is by focusing on pure analysis of the chain of thought. And then I think, all these kind of things like coincidence or whatnot. Kaggle and Google DeepMind a while ago, like about a month ago, announced this competition on Kaggle called. Wait a second. Competitions. So they organized this competition called Measuring Progress Towards AGI Cognitive Abilities. Okay, and it's actually based on the idea that there's a paper from by Google here, where it's like, hey, there is different tracks, different things that we want to measure, and then we are essentially sort of going to build a model of like how like how intelligent a system is from a like cognitive analysis perspective, right? And there's different things like learning, attention, generation, perception, whatever, metacognition, and in a way, it kind of fits a bit the GHC. Sorry, sometimes I'll pause because I'm trying to listen if baby's crying. Um, and it kind of fits quite well with what I am trying to do with the GHC benchmark, right? Which is basically this. It's basically the idea is measuring what LLMs actually think. It's like really sort of like how genuinely human their cognition process is, right? Or at least the way they simulate these is. This all started off of the idea that and the realization that because LLMs are trained on on online text, and they're trained on textbooks, and they're trained on text which is at least one or two steps away from sort of the way that you're really thinking, um, they have a hard time having actual genuine thinking. And and and, and there's this exercise, there's this concept of externalizing your thinking process, externalizing your cognition by just trying to think out loud in terms of, or sort of say out loud what you're thinking when you're trying to solve a problem, for example, right? And this is what LLMs can do very well, because all they haven't really been trained for these, so they and even less like fine tuned. They've been basically fine tuned in like chats, where especially LLMs, because most of the interfaces are like chat interfaces, right? So what all of these LLM providers or companies do is they they do fine tuning after the model to just make sure that they feel like a chat assistant. And that, in my opinion, kind of cuts a lot of their actual raw power, because already not already, like, yet alone the base data set is far away from like having traces of humans actually thinking and solving problems. um the chat is even more removed from that, because you're thinking what you want to say, you're typing what you want to say, you correct the text, you rewrite, then you send, then you read what the other side is saying, you think about that, think about an answer. There's tons of things that go into these, and you're not really, it's not something that is useful for solving problems. And so, and even the more sort of state of the art models where they do a lot of the thinking and whatnot and stuff like these, there's still these trays of like, there is some kind of a chat mess in the middle, and they're trained on maybe scientific papers, which has its own downside as well, right? Because I don't know if you've ever seen a scientific paper, but they're like they're crazy. Like if you go to archive, they're crazy condensed. Like just take anything from physics, for example, quantum physics, anything from here. Recent papers, I don't know, any of these non-symmetric quantum interfaces with bipolar atomic array. Just take these, like the mental refinement that has gone in putting something like this together this is so filtered and far away that from like that, even if you're training a model on papers like these, so that they you can kind of like, it's like next token prediction, right? And then in a way you're simulating learning and exploration and whatnot, but it's so far away from actually how humans think. And one way that I like to think about this as well is if you go to YouTube and you take a look at Terence Tao videos. He has in his own channel, which I don't know if I can ever find it. Lean proofs. He has a few videos where he's doing like formalizing by hand. Like he's actually doing like a full session of like thinking out loud and basically just solving something by hand, right? And this is the kind of data that we need. This is what we want to actually aggregate. This is what we want to train AIs in terms of, because these really get close to like how your brain is trying to think and solve a problem and learn something as well, right? And so if we're talking about education, this is the type of data that we're missing, or there's sort of like a gap in between like what the LLMs are capable of because of the way they're being trained. And one of the solutions to this is have better data. Anyway, I talked too much about this already, but the idea here is that I started working on the GHC benchmark a while ago, kind of put it aside for a while. Where is that? I put it aside for a while because then I went on to build OpenLesson, because OpenLesson in a way is a mechanism to capture data for the GHC data set, obviously. And I briefly had sketched an early idea of what the GHC benchmark could look like. I started off by saying, look, an obvious thing you can measure is how linear the chain of thought is, right? You'll notice that some LLMs, their chain of thought is very linear because it's like an internal monologue, where it's like it's being reprompted itself, and it's like, oh, these and then these and then these and then these and then that and then that and then that, and it barely, like, it's either a very long line of thought or maybe 2 or 3 segmented lines of thought, but they are all each individually very long and very deep. And that's where it started. And then the competition came along. And so I said, look, it just makes sense, right? What I did is I kind of started working on these. There's a couple of streams in the past where I was playing with the interface here, and I was playing with some ideas. So what I ended up doing today, a bit last minute because actually the deadline is in 1 hour from now, what I ended up doing today is basically submitting my write-up. So actually finishing up the project, and that's what I want to talk about. So basically, this is the write-up that I submitted. That's going to become public within 1 hour. I believe after the deadline, they just become public automatically. Then the benchmark is attached to it. This benchmark has 5 tasks, which we will go into right now in a second. And yeah, but let me stay here in a little bit, because I think I'm trying to take a bit of a different approach to all these than a traditional benchmark. And I'm like, to me, I think what matters the most is less about the puzzles and the tasks that you give, but actually how you're measuring how you're measuring what you're measuring, right? And so what I'm measuring here is, or the core principle of the GHC benchmark is that it's important that whatever you're tasking the agent, the system with, the LLM with, you do this within a single prompt. Why? There is a bit of math you can do around probability distributions and whatnot. The core idea is the end behavior, what you're gonna get at the end, is not the same if you ask it in a single prompt that if you ask it in two different prompts. The reason is, and that's what's kind of outlined in here, that if you pack everything into a single prompt, the fact that so it's I think the easiest way to explain it is that it's encapsulated. So it's a bit closer to how a human behaves. If I'm asked to solve a problem as part of the Think Aloud protocol, and I am asked to externalize my thinking, and I'm asked to speak out loud what I'm saying, what I'm thinking, and to then evaluate what I'm thinking, it's like I'm doing 2 things at once. I'm actually solving the problem, and I'm also thinking about solving the problem, right? And this is what surfaces like metacognitive signals, right? This is what surfaces metacognitive signals, because essentially you're demonstrating that you're able to think about your thought process at the same time, right? Whereas if you do this in 2 prompts, it's a different thing, right? It's like saying, okay, solve this problem, and I'm like sitting there and solving this problem. Maybe I'm thinking out loud, right? I'm just thinking out loud, I'm solving the problem, thinking out loud, and just solving the problem, blah, 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 blah. And then I'm like, okay, now here you have a piece of paper. That's what you did. That's your solution. That's what you thought. Now let's analyze these, right? It's a different activity, right? It's a different thing. It's not the same. So, and it does not, the second option does not really tell you truly whether you have metacognition abilities. It's telling you whether you're able to analyze text, or whether you're able to understand the concept of thinking patterns and looking at like and looking at an output and rationalizing about it. And this might as well be someone else's thought process and not yours. It doesn't really matter. So you can see it's essentially 2 differences, right? That's why that's why the experiments for this kind of benchmarks, in my opinion, have to be built specifically with this in mind, that it's got to be all encapsulated in 1 prompt, and that this is the more reliable way that you're going to have to measure metacognition in a model. That's the core principle of these. There's a bit of explanation in here. Then we get into the tasks. So I've designed this with 5 tasks, but as I say here in no, not here. As I say at the very end, it's an open framework. It's not a closed test, right? So it's deliberately designed to be as an extensible framework. So the idea is you can have specific domains like logic puzzles, route planning, arithmetic, whatever you want. What matters is the core promise, or the core premise, that it's a Think Aloud protocol, so as raw as it gets in terms of the thinking of the data, and at the same time is as raw as it gets, and at the same time is basically it's all encapsulated in 1 prompt, right? So this is the more important piece in here. So the 5 tasks that we have are these ones, are basically, they are also common, like, so, and I discussed them in some of the previous streams, but essentially task one is the COT linearity analysis, so logic puzzles, and then essentially trace, so the chain of thought is scored for non-linearity, right? So we're looking at, I believe I did draw that once, JS Paint, where essentially you want to look for traces that are more like, you have a starting point, and then it gets to a point where it just maybe does one thing, backtracks, does another thing, maybe backtracks again, try something else. Actually, maybe that takes it back to this one, which reinforces maybe this path, and then does something like this. Oh no, let me go back here, do something like that. So it's, instead of like doing like one thought, another thought, maybe another thought in here, maybe another thought in here, maybe another thought in here, and then and on, and like, this is very linear. This is more what we're hunting for, right? And that's what this is scoring for. Then we have a zoo planning with metacognitive monitoring. So that's a task that is basically asking the model to make a plan how to feed the animals in a zoo with a bunch of constraints, which is tricky to kind of like not, it's actually it's used in kids in children metacognitive analysis in real life, I believe. I did find a few papers that I read through that are referenced below. The idea is make the model reason about the mistakes it's making, and sort of what it's doing is it's the judge is scoring against monitoring quality, control quality, and self-awareness of the thinking process, right? So this is strictly the structure of the thinking process. This is the quality of the thinking process. Then verbal traces comparison is it's kind of the same. And these two things both measure quality, right? This measures structure. These two measure quality. Although this one does it more from a process and planning perspective, and this one does it more from a logic perspective, right? Like breaking down steps, etc., etc. Then there is a metacognitive self-interrogation task, which basically the model solves, interrogates its own reasoning for hidden assumptions and errors. So this is more focus on error correction, and here it's scoring on against the interrogation depth and whether what you're criticizing sort of improves the answer. And finally, so I would kind of say, and maybe I should rewrite this a little bit, but I think essentially tasks 2, 3, and 4 are focused on quality, and task 1 and 5 are focused on structure, right? So in this case, it's focused on first, it's asking to estimate how long it will take to solve a problem, and then jumps into solving it. So like trying to understand the structure, how deep, how actually deep the or how long will it take to solve the problem, right? I had something a bit different in mind. I wanted to work more on really understanding how long it takes a model to solve a problem. The problem is you've got a lot of noise that you have to be careful with in terms of the model providers, availability and things like these. And I'm not so sure so well how to do these inside the Kaggle framework. Probably I will do some local tests with local models if I can, because then I know that basically it's just whatever I can remove the noise because I know what components are involved, right? And yeah, and basically that's it. So the data set is all procedurally generated. So it's all logic puzzles, zoo graphs, a game of 24, cognitive trap problems, and FRTF problems. There's a few technical details in here in terms of like, how are we maintaining the score and stuff like these. And essentially, then this also the data set. I think the way that this is, it's built in a way that it's configurable so that you can actually crank up the number of items and jobs so that you get more runs currently what's here on Kaggle is on a low number so that it can run relatively quickly and cheaply. So the results don't maybe necessarily are super accurate, the ones you see here in Kaggle, but like that's the idea, right? And yeah, basically that's it. So here you have the benchmark. That benchmark is going to get public in an hour probably. I've run it against some models already, and you can see, I mean, some are failing completely, so I would have to double check what's going on. But I mean, it's clearly DeepSeek is a winner, but it's still not too crazy, right? So it's doing really well on the task calibration, on the task 5 effort calibration, and it's doing really, really well on the self-interrogation. But you can see that the zoo planning, the linearity are not too high, right? So it doesn't come off as a very saturated benchmark. Gemini scores crazy well at self-interrogation as well, but it's interesting to see that the linearity one is really doing a good job, because it's actually not how most of the LLMs think. There's no model that goes above 35, no 40. Okay, so 40, yeah, sure, and then 37 Claude 4.5. Interesting. It's interesting to see. Like, let me run it. Can I run it for 4.6? Did it improve? Yeah, anyway, but you see what's the deal here, right? So the idea is, the core principle here is that it's not so much about the domain of the tasks themselves, but it's about measuring everything. So measuring metacognition within a single prompt. I think that's the core tenet of this process. Will this win the competition? I don't know. I have no idea. People have been very silent about this competition. I haven't really seen a lot of noise and whatnot. I have no idea who I'm competing with in terms of like the level of quality of work they do. All I know is, to me, that was an excuse as well to build the GHC benchmark, which I always wanted to anyway as part of the Uncertain Systems project. And that's kind of a way to benchmark myself against experts out there. So we will see what happens. But essentially, that is actually the GHC benchmark. It has its repository on GitHub, open source, so you can actually look at the same thing here. So it's all open source in here with the tasks and whatnot. And I've also built a little website that is linked in here, or just go to ghc.uncertain.systems, and you'll end up, I'll make it look a bit more visually connected to the Uncertain Systems vibes, but essentially that's just, the methodology, explain a bit of the math between the single prompt, the two-phase prompt, and then the 5 tasks, and basically like the fact that the idea is sort of like a bit of a shared architecture around, like, okay, a think aloud prompt, model generation, and calibrated judge, right? So it's important that kind of these things are basically the core of like every single GHC task that follows this exact pattern. Okay, cool. I hope that was useful, and enjoy the benchmark, enjoy the project, and we keep building. See you guys tomorrow.